Welcome to our YouTube channel, Ed with Fun. Today, we are going to discuss about the wave equation. V equals F lambda. So, what is wave equation? It is differential equation expressing the properties of motion in waves. Also it describes movement of strings and wires, and the movement of fluid surface, for example, water waves. Let's define the variables of the equation. V represents the speed of the wave, F represents the frequency of the wave, and lambda is the wavelength. Speed of the wave can be calculated by multiplying values for frequency and wavelength. This figure shows the speed of sound wave through different mediums. As you can see, through solids, sound travels faster, and that's why sound of a train be heard by putting your ear on the track well before you could hear its sound in air. Speed of an electromagnetic wave in space is equal to the speed of light, c. c equals 3 times 10 to the power of 8 meters per second. Standard unit is meters per second, which is written as m over s or m into s to the power minus 1. Did you know? Electromagnetic waves emitted by the sun are of a broad spectrum. The most intense of these to reach the Earth's surface is visible light. Let's identify a waveform before moving to the other part of the lesson. Here you can see a waveform marked with letters. So, the length showed from letter A is the wavelength. Wavelength is equal to a complete cycle. Letter D shows the crest of the waveform. Letter C shows the trough of the waveform. And letter B shows the amplitude, which is the maximum displacement by a point on a wave, measured from its equilibrium position. Frequency can be defined as the number of complete cycles per second. Standard unit of frequency is Hertz, which is written as capital H with simple Z. 1 Hertz means 1 cycle per second, so 10 Hertz means 10 cycles per second. Wavelength is the physical distance between matching points of adjacent cycles of the waveform. It represents a complete cycle. Its standard unit is meters, which is denoted by simple m. Let's move on to an example. When a tuning fork of the frequency 512 Hz is vibrated, the wavelength is 0.65 meters. Find the speed of the sound wave. Here, frequency is given as 512 Hz, and wavelength, lambda, is given as 0.65 meters, so we know the equation, V equals F lambda. Then we substitute the values and multiply, we get the answer 332.8 meters per second. Did you get the answer correct? Let us know in the comments section. And don't forget to like, share, and subscribe to our YouTube channel, Ed with Fun.